Hey guys, today we're going to get into what the difference is between interference and iridescent paint colors. But before we dive into that, we kind of have to look into what is color in regards to paints and how is a paint color perceived to the human eye. So obviously you kind of guys have already learned this in like middle school science class, but basically natural light through a prism projects a rainbow, and each color in the rainbow has a different wavelength or light. And so when an object interacts with natural light, certain wavelengths are absorbed and others are reflected. And the reflected wavelength is the perceived color that enters our retina. And humans are trichromatic, so the cones in the retina is what sends a signal back to your brain to perceive the color. So an object doesn't really, you can argue philosophically whether objects do have color or not, but take for instance a banana. When natural light hits the object, all wavelengths are absorbed except for the wavelength that is perceived as yellow, which is in the 590 to 560 nanometer range. And so when we're talking about light and iridescence and um, interference today, we're going to be talking about light in form of a wavelength rather than a particle. So when you talk about light and wavelength, the wavelength of a light wave is the distance from crest to crest of within the sinusoidal function. And then, so with the sinusoidal wave, the distance from the base of baseline of the axis when you represent a wave graphically to the top of the crest is known as the amplitude. And then you can see the direction and the distance the wave is traveling along x. So now that we kind of know how light operates and interacts with objects, we can now go into what iridescence and interference is in terms of paint colors. So iridescence is kind of a property of a paint that allows it to change color based on the viewing angle of the paint. And so within that, there's a subsets of iridescence where there's pearlescence, which is when light hits the object, it comes back in terms of like a shimmery white color. In terms of iridescence, it's typically like one solid color. So think like gold paint, silver paint, that's iridescent. And then duochrome, think kind of like MAC eyeshadows. It shifts between two colors, where it could be red in one viewing angle and green in another. So this is more reflection. It's kind of like shimmery to the eye. Whereas interference, as you're going to see, works a little differently. So when we go into interference, a wave is kind of defined as a cosine of kx minus wt, where a is the amplitude of the wave, k is the wave number, so that's 2 pi divided by lambda, lambda being the wavelength, and then w is the frequency, the angular frequency, which is just 2 pi f, where x is the distance and t is time. And so if you have, with interference, you can have constructive interference or destructive interference. So if you have wave 1 plus wave 2 in constructive interference, you're going to have the end result be 2a cosine kx minus wt. And notice the 2 means that basically you're doubling the amplitude by combining the two wavelengths together. And so this is when you have the phase is an even multiple of pi. So think like 2 pi, 4 pi, negative 4 pi. That's one that you'll have constructive interference, whereas destructive interference is when both waves add up to 0 because the waves are 180 degrees out of phase. So when you have interference paints, the same kind of thing is happening, in which you're having the paint interfere with the paint being the object. It interferes with the natural light in such a way to where it can either have constructive interference or destructive interference, changing the perceived color based on the lighting angle. And so now that we've kind of gone into what all these things are, just kind of another example of iridescence is think of like a soap bubble. I'm gonna bring up something here. But basically, there's something called thin film interference, which is when, think of like in a soap bubble, light waves would be reflected in and out of the film of the object of the soap bubble and be refracted in such a way to where the perceived color to the human eye is altered from the original source. And I just think that's such a cool example in our everyday life, is that's how we get the perceived color to the retina. And then lastly, so I just wanted to bring up kind of an example of the paint colors here. You can see kind of the numbers 3 through 5. They are the iridescent colors, in which, regardless of whether it's over a white or a black background, the color interacts the same, in which it reflects back the same shimmery color, regardless of what is behind it. And then the rest of them are the interference, in which, based on a dark background or light background, the paint interacts in a different way, in which it reflects back a different color dependent on the darkness of the background. So you can see like the red shifting to green there. And if you want to check out some really cool brands that have interference and iridescent colors available, if you're looking into acrylic colors, I check out the brand Golden for Daler and Rowney has some good watercolor options. But thank you guys so much for tuning in today and joining me for this Draw and Learn session. This is the first session in the series, and I plan on doing more like it in the future. So if you liked this video and you want to see more like this, just give it a thumbs up down below and subscribe for more content. I just want to thank you guys so much for watching. Thank you guys. See you in the next video.